Hello, welcome to the MapSat program where we implemented the dynamic program as well as the greedy program. So just a quick run through this, tell you the basic gist of it and how I did it. First of all, starting off the main, just declare and initialize the 3 arrays as well as the maximum weight, and then I used these greedy steps and DP steps in the knapsack and greedy to basically return the value of how many steps it took. Didn't want to use tuples because I don't like working with them, and I thought this was just easier to do. So I used out into steps to basically return another value already rather than the totals. So then we just start the knapsack, return the values, greedy, return the values. Going into the knapsack, DP, clear and initialize some variables. We're going to just set DP to equal to the maximum weight plus 1. So we can make sure to get all of them rather than just going up to, since it's 280, just going up to 279, that actually gets all of them at 280. Loop through this, it's a triple loop, so it's going to go through the weights, how many there are on the weights, and how many quantities there are in each one. So one could have like 1 or 2 or 3 that we have so far. And then it's going to start at 280 each time. And then it's just going to go through and make sure it can actually do the weights of each one, and then just minus 1 each time. And then it's going to take, in the first loop, it's going to have none in there, so it's just going to always take the max of this. And then the next one, and then it will go over and then compare the already value that was stored, and then rewrite it over, and then basically keep going that until it ends. Increment the steps for how many times it does it. It's going to do it a bunch. And then return the final value that it is at the very end. So DP of 280. Greedy knapsack, basically the same setup, but this one has the ratio to basically get what's the best ratio I can get, and then declare and initialize some variables, go in this while loop as long as it's greater than 280. Set this as a negative 1, so we can break out of it if it's still equal to negative 1 after we check if there are any remaining units to use. So we're going to check how many quantities there are and how many that we already used. As long as that's greater than 0 and that's equal to negative 1, which so it is going to be, or the ratio is better than the one that we already have. And then we're going to set best equal to I. Go in this if the weights of best, so in the first loop, weights of 0 is 20, is less than or equal to maximum weight, so it's 280, so yes, it is lower. Then we're going to minus it by 20, so it's going to equal to 260, and then total is going to be values of best, which is going to be 70, so total's at 70 right now, and then we're just going to increase that use of the quantities we already have. So else happens only when we don't have enough to do another, we're going to max out the weight, have more than we're going to do. Increment the steps and return the total. So I'll quick and just run, show that it does do it correctly. I misspelled dynamic. So yeah, that's 650 steps, 2,260. Greedy value has a little different, getting the ratio. Takes a lot less time. It's more approximate and much faster, while dynamic programming will take much longer. Say we move this to like 370, we're also going to get a different value. So max value 840, steps 3,160. This one's 848.3 approximate value, and steps of 8. So thank you.